Today we're going to be talking about iron deficiency anemia. So to begin, anemia in general deals with low blood oxygen. In some way, we have a lowered ability to carry oxygen in our blood, or we just have lower oxygen in our blood. And iron deficiency anemia is a specific type of that deals with, you guessed it, iron. But what does iron have to do with our blood's ability to carry oxygen? Well, most of the oxygen in our blood isn't just floating around freely. Let me draw a big blood vessel here. And we'll draw some red blood cells in. So these are just red blood cells floating around all by themselves. And oxygen does exist somewhat floating around freely in our blood, but it's not too prevalent here because this is a really inefficient system. This has to rely on oxygen actually entering our blood through our body. It can leave. So this is really only how we carry like 2% of the blood in our body. The big boy, the big thing that carries, that's not going to be very pretty. The big thing that carries oxygen in our blood is hemoglobin. And hemoglobin is found in our red blood cells. I'm writing HB for hemoglobin. And hemoglobin is the big carrier of oxygen in our blood. So how does hemoglobin work? Well, hemoglobin has 4 sections. I'm just going to draw them like this. And each of these sections has the ability to carry one oxygen one oxygen molecule. So for each hemoglobin, we're able to carry 4 oxygens. And our red blood cells have a ton of hemoglobin in them. They have around 270 million hemoglobin per healthy red blood cell. So this is actually how we carry 98%. See, there's the 2, there's 98. 98% of the oxygen in our blood. So you may be asking, if hemoglobin's how we carry all this oxygen, does iron have something to do with hemoglobin? And yes, it does. On each of these sections of hemoglobin, they're called heme groups, we have an iron atom. I'm representing iron with orange here. Orange equals Fe for iron. And each of these iron atoms binds to an oxygen and holds it. So we have 4 iron atoms for 4 oxygen molecules. So if we don't have iron, we aren't able to make hemoglobin, which means we aren't able to carry 98% of the oxygen in our blood, so we have low blood oxygen. Now, we lose around 1 to 2 milligrams. Oh, that's low. We lose around 1 to 2 milligrams of iron a day. So we need to eat 1 to 2 milligrams of iron a day in order to keep our stores of iron roughly equal, right? So we're able to produce the amount of hemoglobin that our body needs to survive. And if we don't, then we develop this condition called iron deficiency anemia, whether that's from not eating enough iron-rich foods or we have some problem with reabsorption in our gut, we end up not having enough iron in our system and we get the symptoms of iron deficiency anemia, which are dizziness, fatigue, and shortness of breath. Among some other things, we have like pallor of the skin, pale skin, because oxygen is what gives our blood its bright red color. So if we have less oxygen, we're going to have paler skin, right? But these two here, dizziness and fatigue, have to do with low levels of cellular respiration. So let's talk about what cellular respiration is, because that is why, let me make sure I spell this right. There we go. Cellular respiration is why we need oxygen in the first place. That is the equation, the chemical formula, or the chemical reaction that goes oxygen plus sugar, spell this right here, oxygen plus sugar yields CO2, remember we breathe that out, water, ATP, a molecule called ATP, and heat. Now ATP, this is a molecule, you don't have to worry about what it is right now, but just know that this is energy. This is what our neurons, this is what our muscle cells use to power themselves, to perform their functions. So if we have low oxygen over here, we're going to have low energy. And this is why we see dizziness and fatigue. It's because we have muscle weakness. We have brain fog. Our brain and our muscles and our other cells in our body aren't able to perform at their peak functions. So we have low levels of cellular respiration. This equation is not proceeding. We are not getting energy. We also have shortness of breath, and I've written shortness here. Iron deficiency anemia doesn't necessarily cause shortness, but it does cause shortness of breath. And that's because we have receptors that check for O2 levels. So if we have low O2, our bodies have receptors that can tell, yeah, hey, this reaction is not proceeding. We need higher oxygen. So we increase our rate of breathing. So shortness of breath, we aren't able to get a full breath in. We keep breathing because we're trying to compensate for the lack of oxygen that we actually have. In our this chronic level of low hemoglobin, we don't have enough oxygen in our blood. So what are some ways to fix this condition, or we'll say treatments? What are some ways to treat this condition? Well, the big ways are to get iron in our system. So we can do that through iron-rich foods. These are like meats and leafy greens. And if we have a big problem with this, we can even do iron supplements. If we have a problem with not absorbing enough iron from these foods for whatever reason, we can take supplements to help with that. So this is iron deficiency anemia. To summarize, our body needs oxygen because of the cellular respiration. We need iron to produce hemoglobin, which is the thing that carries all the oxygen, right? If we had no hemoglobin, which that's not realistic, we'll always have some iron. But if we had no hemoglobin, we would be working at 2% of our normal level. So we need iron to facilitate this oxygen carrying, or else we don't have the energy and we feel very bad. So this has been a little summary of iron deficiency anemia. Thank you for listening.